I introduced both Rick and Rob earlier, yesterday when you heard them on the advanced mobile discussion. And so they're going to talk about the experience at Con Edison in New York with the residential methane detector, both initially non-connected devices and how that turned into a connected device. So with that, I'll turn it over to Rick and Rob.
Thanks, Paul. Yeah, Rick's running out of comedy material, so he asked for an opener. That's why I'm up here. So me and Rick will take you through Con Ed's evolution in implementing this safety program. And just to start, I think the evidence was just shown in the numbers that Mark just showed us, right? That study from Japan tells a better story than I could ever. They had a number of incidents. This device was mandated, and the incidents now are virtually non-existent. So that's the goal for the industry, right? To get our incidents down to nothing. And this device, from my perspective, is the biggest safety leap forward that we've had in decades. And honestly, if I'm being honest, probably ever, because it's taking the human element out of a lot of the process, right? It's automatically notifying the utility of a potential hazard so that we can respond immediately. And we've never had something like that before. There's always been a human element, excuse me. And being able to take that human element out of this process is an incredible leap forward, particularly for a utility like Con Ed in the environment that we operate in. Rick went through a lot of this yesterday. I just want to highlight a couple of things. One, as Rick said, we are an electric company, but we did start as a gas company in 1823, and last year was our bicentennial, so 200 years as a company, which is something that we took a lot of pride in. And we started as a gas company, so we've evolved over time, but that was something that we're very proud of. Our service territory is incredibly dense population, but not only that, there's also an incredibly dense infrastructure in where we operate. So if you ever seen a picture of the ground in Manhattan or in the Bronx, there's a ton of things in the ground. There's electric, there's steam, there's telephone, there's cable. All of those are pathways to structures. So there's always so many point of entries for gas to migrate from our infrastructure into buildings. What does that mean? Elevated risk for us in the area that we operate. That's why this tool is so instrumental for us, that it can eliminate that human element that we have for somebody to notify us. We do leak surveys, obviously, all the time, as I mentioned yesterday. We scan our systems monthly. We walk our services. But having an automated process for when gas is gathering in a structure, which is obviously the highest risk that we can have, is just instrumental for us moving forward. So where did we start with this natural gas detector, right? As you might imagine, there were catalysts for us to implement this program. Two of the events, unfortunately, that happened in our service territory in 2014 and 2015 resulted in 10 fatalities between the two of them. East Harlem was a distribution event, and the East Village explosion was a theft of service, actually. That was plumbers stealing gas in a house. So two very different causes of gas escaping, but both with the same tragic outcome. Both of those we know could have been prevented with a natural gas detector if it alerted us immediately, right? We always have barriers that we put in place for defense, right? And one of those barriers that was in place at this time was for the public to notify us when they got an odor of gas. One thing that we learned coming out of this event was there was a huge gap in that line of defense. These dots up here, as you can see, the dots in red are 10 people who said that they smelt gas and didn't react to it. The dots in green are people who didn't smell gas, even though there was gas present. And then the one in yellow was a customer who called us up approximately 15 minutes prior to the event, but they said that they smelled gas for a full day before they called anyone in. So there's obviously a gap in that process. And I can tell you from my experience as an emergency response supervisor that this isn't uncommon. I can't tell you how many times I reported to a leak location, spoke to a customer, and they would tell me, oh, I've been smelling gas for months. Oh, someone else came in and told me, so that's why I called. My mother came over and smelled gas, so I called. I thought it was nothing. I was in the kitchen. I thought the stove's supposed to smell like gas. So, one of the initiatives that came out of this incident was in education, smell gas, act fast, we called it, and we, tried to educate the public on, if you ever smell gas, ensure that you notify us. But that still leaves up, a human element in this process, which is inherently flawed at best. So that's why we realized, I know we're not in Houston, but I think we're close enough, that we had a problem here with, with one of our layers of defense. And that led us to begin this initiative, and I give Rick a ton of credit because he was the tip of the spear for Con Ed to get this device approved and through all the barriers that we needed and to get this program implemented for us to start to implement this program to every service that we have. We know that once this is completed, that our system is dramatically more safe than it was before. So this 6-year program that we're gonna complete in 2026 is going to dramatically improve the safety of our utility. So I'll let Rick walk you through some of our journey as we got here.
Okay, so as Rob mentioned, we realized we need to do something different. Well, that began our long and winding road. Let's see. Yeah. All right, it was supposed to play automatically, sorry. Technical difficulties. So classic rock fans, yes, I have some music. All right, and that was, it was a long road, it really was, because I sat before our chairman after the second incident, and I was tasked with looking at natural gas detectors and said, okay, what do we do, what's out there? And in the first place, I looked on the internet, right? What's for sale, right? That's the first place you look, and then after that, what standards are they used to? And then after looking at standards, realized, oh my God, there's a huge disparity, right? Looking at Underwriter Laboratories, which was the standard to list devices at, assuming they were even listed, and some on the internet are not listed, realized that we have a problem because the standard had a 25% LEL alarm limit, and for us operators in a room, that's just an insane amount of gas in the building, right? 1.25% gas and air. So we realized, that had to change. So that was one effort. Luckily, we had, then we started internal projects to evaluate what's out there, commercially available. We did nice search projects to understand how vapor disperses in buildings. We did Operation Technology Development Projects, which is the not-for-profit research collaborative of the Gas Technology Institute, GTI, to test commercially available units, both nationally sold and internationally sold, to see how they perform, how they react with typical household chemicals, would they be interfered with? Because the industry, well, at least we did, had a lot of fears of what happened in the early 80s, or late 80s, when carbon monoxide detectors were rolled out. And we did not want to have false alarms. We were afraid of that, because that really impairs people's confidence in technology, false alarms. So then, luckily, New York State staff, Public Service Commission, they came immediately on board. They said, we told them we want to pursue natural gas detectors, and automatically they saw the merits and the benefits. And one of the first things I was tasked with in R&D was a $2 million giveaway of natural gas detectors. So at that time, we gave away a backup battery electric-powered unit, which was the best available at that time. It alarmed actually at 20% of the LEL, which was the best available at that time. And I will tell you, I look back at those 61,000 units, and all right, quick poll. How many alarms do you think we got for those 61,000 units? Anybody? I heard 10. Any others? 37. 0. We gave away 61,000 gas alarms and we got 0. Never got a call on them. All right? So it just speaks to the units. And also, quite frankly, there was no standard for installation, so we were using manufacturer's instructions. If it's a battery-operated unit and it doesn't have a power cord, where do you plug it in? Down there. Where are you going to detect gas? Up there, right? So, so then we had the East Harlem settlement, one of the catalyst events that Rob discussed. So then we had an order from that, and the order required we do a lot of safety aspects, and some of that was actually the monthly survey we do of our distribution system Rob spoke about yesterday. That was part of that order. But the other part was to give away more natural gas detectors in the area where we had the incident, the East Harlem section of New York City. And those detectors we gave out were not the plug-in backup battery ones, those were the new Cosmos units. And those are, and then of course the new Cosmos units are the ones we're using now, like the Nova Detect units. And that was done through an RFP we sent out to manufacturers asking for battery operated, right, which was a leap, and 10% of the LEL. We had multiple people come back to us with proposals, and ultimately we settled on the new Cosmos unit. And at that time, Underwriter Laboratories was still at 25%, and we said there's no way. One thing to mention about our AMI units, I say AMI to be clear, automated metering infrastructure. So we call them AMI units because we have the commercial unit manufactured by New Cosmos, and they simply put the AMI communication module in it, right? So it's really their technology with a third-party Itron communication module in it. So that was our requirement. And we started giving away those, we started installing those in 2018 with a 9,000 unit pilot because we're putting a gas detector in someone's house. We didn't know what the heck was gonna happen. You know, how many alarms we were gonna get, how we're gonna respond to the alarms, you know, were we gonna have false alarms, even though we tested it, it was still not in a residential building. So that was the beginning of it. So then, now we're putting a gas detector in someone's home. How do we respond to it? Do we put it as a normal response? If it goes off, you know, we send a crew, or do we prioritize it? And obviously, the decision was, well, we have to prioritize it because if someone calls gas, reports an odor of gas to us, is it gas? We don't know. You know, it could be a dead animal. I've responded to dead mice in stoves. Don't ask me why they were there, but they were there. So this here, we're putting a gas detector in someone's house. If it goes off, it's gas. It was that simple because we had tested the unit, we were confident in the unit, so we had to develop a response protocol. And part of that response protocol was we met with all the governing fire departments, and the major fire department we met with is the New York City Fire Department, which of course is a huge organization. But in our Westchester County, there are local fire departments. So we met with them and we told them what our plans were and what we're doing, and that we would like to notify you when one goes off. And they were like, hey, we're all there. So when one of these alarms goes off, the first call is to the governing FD, and they go first because they're there in 4 minutes, right? We're right behind. We're typically there in 15 minutes, but they are there in 4 minutes because, once again, we got the gas detection in the building. The other thing we had to do is we had to create a new alarm. I mentioned it yesterday. We have, you know, we're very sophisticated in our classification of alarms. We have GLI, gas leak indoor, and GLO, gas leak outdoor, okay? So we just needed a third ticket called the GLA, gas leak alarm, because when the unit goes off, it goes automatically through the AMI network, comes out of the AMI network into our head-end system, goes through a couple of systems internally to the company, and automatically comes out in our emergency response center as a leak ticket, as if someone received the phone call and there was a customer service rep entering a complaint, right? So it goes seamlessly through. And I will tell you, if any of the operators in the room, the gas operators, if you're thinking about this, this project was not a project to develop a natural gas detector. This was a project to develop an interface of that unit into our emergency response center. That's really where all the work went into. And I'm not minimizing the natural gas detector work, but we didn't have to do that. We had a great partner to do that. You know, I mentioned a pilot program, 9,000 units, 8,000 in Westchester, 1,000 in Manhattan. We're receiving an alarm rate of about 1.6% units on the pilot. So 1.6% of the units we put out gave us an alarm. Right now, we're about at 1.52% alarm rate. So we're not getting a lot of alarms from them. But obviously, the alarms we do get are gas, so they are serious. We had... I had 0 failures, but Mark said there was 1. So I'll stick to my 0. Okay. We're rounding. Maybe we're rounding. Yeah, I rounded 0.4 down. Okay. And zero battery failures. Now, one thing I mentioned, we discussed underwriter laboratories, and the base unit we have installed was listed in accordance with UL, right? We tested it to UL, but then we had to modify it, right? So the units that we received in our packs and New Cosmos is marketing the commercials are listed units. The units that Con Ed has are not listed to UL. They were tested to a UL standard, but then there's functionality in UL we had to take away, right? If an alarm goes off, we want the consumer to hear it, yes. If the battery fails, we don't want to bother the consumer. It's not the consumer's problem, it's our problem. So that audible signal goes remotely to us silent. The consumer doesn't hear it. If there's a sensor failure, the consumer doesn't hear it. We also had to make sure the consumer could not turn the unit off and we had to change the functionality on-off switch because sometimes there was some herbal experiences going on 2 o'clock in the morning with chips, and they're like, hey, what's this, man? And next thing you know, they have the fire department at their front door. True story. It was sort of like Bill and Ted's Great Adventure. So lessons learned in putting them out. When we first started putting them out, we were getting a lot of leaks because our installation procedure did not do as thorough a leak investigation. And what we thought was piping that, well, it shouldn't be leaking, it's indoors. It's leaking. So we actually got a lot of leak calls because our installation procedure was not adequate in doing a pre-installation leak survey. And then internal program communications. The other ones that started setting off the unit was our crews. They're doing replacement work inside. They didn't understand what the detector was, how to isolate it, how to protect it from being exposed to the work they were doing, because they take the meter apart, they release the gas in the basement. Yes, we do. Unfortunately, there's a little bit of release. And we set units off that way. And then the last was a mistake by this guy named Rick. He really screwed that one up. He looks a lot like me because, he said, hey, do we need the readings? I'm like, we don't need the readings. It goes off. We're going. Oh, we need the readings. Right? So we now have the readings coming back, and Rob will show you some of that. So alarm flow. What's critical is we are the electric provider. I mentioned earlier we are an electric company. We started as a gas company. We're very proud of that, and we are an electric company. And so this device does require the electric meter because the AMI module in it is not capable of going up to the AMI network. And our gas meters, AMI module, along with this device, communicate through the electric meter. So that is actually our pathway up, is through our electric meter. So we do require that, and the electric meter gets up to the access point. So where do we install it? One thing that's critical, most of our meters are in the basement. Okay, so we are unique. Some of the older infrastructures have it. Some portions of Chicago, Philadelphia, Boston, the older cities, all right? The newest cities don't. Our meters, the majority of our gas meters are inside in basements, right? So, our target zone is on the pipe around the meter, which is governed by service line definition, and we have to inspect it. So that's what we're looking for, a leak in that vicinity. And I show here where we put it, and if there's an outside meter, we try to put it on the inside piping, even though we don't have jurisdiction to inspect that pipe. But the most part, we have access to consumers allow us to put it in. Because once again, this gas detector is a Con Ed asset. It's just no different than a meter to us, no different than a regulator, and when we track it accordingly. Just a few installations of how we put it in. You could see, these are all indoor meters, of course. You can see the gas coming through in the middle, it comes through the foundation wall, goes up, and we put it as high up as we can. And what's interesting is you say, well, you got 3,400 alarms. That's a lot of alarms. That's a lot of 10% gas and air. The majority of readings we're getting is not 10% gas and air. The detector is getting the leak plume going past it, and it's setting it off. And when we get there and we take a reading in the atmosphere, we are getting no readings in the atmosphere. So the majority of the leaks we're getting are incredibly small, and this is where Rick screwed up. I didn't anticipate that. And that little leak plume is going past the unit, setting it off. So, just for those who are thinking, that's a lot of gas and atmosphere all the time. It wasn't. It's really just a fitting leak for the most part. We call them fuzz leaks, right? And this is what I showed you yesterday. A 250,000 units installed. We're the largest living lab for gas detectors in the United States. So even though there are other manufacturers coming online, I will tell you that when these alarms went off, when we had a detection, the unit went back to New Cosmos to evaluate what it was sensing. So I will tell you, this program gives some level of performance guarantees of the products, not because we've tested it, but because they've had the ability to, anything we thought was a false alarm, they investigated and they can make product enhancements where necessary, right? Which is great. I mean, it improves. Of the 61,000 I gave away, I did get about 200 calls for consumers. It's beeping because they didn't understand about the battery. And of those 200 calls, there were about 3 or 4 where actually the unit was faulty, and I sent it back to that manufacturer. So they never would have gotten it. I mentioned yesterday we've had 510 outside leaks migrating in. Rob mentioned that. Most of our infrastructure is very dense. Lots of penetrations coming into the buildings through all conduits. A lot of the leaks are outdoor leaks. And that was our intent. Our intent was to stop East Harlem from happening again. That was our use case. A building blowing up, let's say it bluntly, from our gas escaping out of our pipe. That's our use case, right? And we had an added benefit of catching building fires. Not because it senses fire, the off-gassing of the combustibles is producing methane because the detector goes off on methane and it sets it off. So that's a side benefit. A quick graphic of how the leaks come in. Because now the bad thing of putting a gas detector in someone's building is it's on all the time, right? It reports back to us every 8 hours, gives us a heartbeat. Hey, I'm still alive. And it senses about every 2 minutes. It takes a reading. Once it detects, it goes into the 30-second detection cycle. And if you look here, the bar chart is how we've gotten our leaks. That was a couple of years ago. It hasn't changed too much, but you can see it's spread over the course of the days. What I did put in here is the giveaways we gave away, and they were, they're more towards the hours when people are up. So that's what those little clouds are. Those 10,000 units we gave away represents the alarms we've gotten from those. I only had 5 recorded. I think we've gotten a few more calls from them, which is great. Okay, Rob?
Thank you. So as Rick mentioned, we've had 3,400 instances where an alarms went off and we went and responded. So what does that number mean to any of us, right? To me, I can look at that number in 2 ways. One is that's 34 instances where we were automatically notified of a potential hazard, no matter how big or small the hazard was, right? Like the majority of these, even ones that I've been to, they haven't been, gas and atmosphere, right? But they've all been gas leaks. So those are instances where we wouldn't have gotten a call, or at least not at that time would have gotten a call, and we're able to respond in real time and make a hazardous situation safe. 3,400 times over the last 6 years. That's incredible, an incredible safety enhancement, right? But on the flip side of that, if you see the other side of that scale there is almost 260,000. That's how many odor calls we've gotten responded to over that time. So the 3,400 is kind of inconsequential when looking at that number. Why is that a good thing? Well, if there was one concern that's been brought up to me within the industry, it's that when we put all these out, we're going to have 200,000 plus of these out there. How are we going to respond to all the alarms? That's the concern, right? And I was in emergency response, so I can empathize with that concern, right? You have X amount of crews on, and somehow it always works out that you get 10 calls in a row. You get none for 2 hours and then 10 in a row when you have to respond, right? It just seems to work out that way. So that was the huge fear that people had. And the data just proves out that that's not the case, right? On average, this would be 1 or 2 additional calls a day, which is, immaterial to anyone who has to respond to it. So I think in both ways you look at it, one, it's inconsequential to your operation, so it's a disproportionate value versus issue that you'd have with this, right? 1 or 2 additional leaks a day is not going to hurt you, but being able to get to an incident before it happens, the value is incalculable, right? You can't it's impossible to determine how much value that adds to a company. So 3,400 times we went to those locations and were able to make them safe before the public would have identified them for us, or before we would have found them on a leak survey or one of our other means of of surveying. The other thing is, this is sort of a catch-all device for us, right? Whether or not it's a fuzz leak on a meter or a cracked cast iron gas main that's migrating towards a building, we'll get there, we'll get alerted, and then we can do our investigation and locate the source of the leak. We'll go through a couple of examples now of ones that we've had. And this first one, I think, is a very important one to illustrate how much value this actually adds. So you can see the response times up there. We get an alarm at 8:59. It's dispatched 2 minutes later, and we're there within 7 minutes. The fire department's usually there within 3 or 4 minutes. So as soon as we get an alarm, within 4 minutes, somebody's there to at least make the situation safe, and then we respond to find the source of the alarm. But this one was unauthorized pipe work by a plumber. So not only would we not have gotten a call on it, but someone who's doing something nefarious like that is likely to try to cover up what they're doing and try to make sure that a homeowner or no one else notifies us, right? Because obviously they don't want to expose what they were doing. It's similar to the incident that I showed you before in East Village, where theft of service led to an incident. So this device allowed us to get there, see that the situation was unsafe, and make it safe. And that's incredible value for us, to have in a situation like that. The next one is just a leak at a gas meter, right? So you go from a very potentially serious situation with someone doing unauthorized work on piping to also just finding leaking equipment within a basement, right? So having that range of ability to catch everything that's out there is so instrumental for us moving forward. Rick has some background on a couple other ones that he's going to take us through.
This next one is, I really think is a perfect example of why they're out there. So you can see the reading is flatlined across. And that it's hard to see the scale. That's 25% of the LEL. The unit doesn't read above 30% of the LEL. So 25 is what we're reporting. After that, the unit doesn't go up any higher. And that's the ability to get that low detection level required loss of a higher reading. But from a safety perspective, that's an adequate reading, of course, 10%. So you can see the water heater, the gas service. So the alarm goes off, call the FD, they go out there, and that water heater, the 3/4-inch pipe to it, broken, open-ended, and blowing in the basement. The consumer the prior day had done some masonry work on a fireplace above. Whatever they did, it fell through the floor, severed the pipe. Consumer's upstairs, second floor, sleeping, hears the loud bang, wakes up, and then, of course, starts smelling gas. And they're on the phone with 911 when the FD that we called knocks on their, goes in their door and gets them out. And at that point, the FD told us they measured 2.5% gas in air. So that was within 4 minutes, right? So that was clearly on its way to an explosive limit in a very short order of time. So that was, to me, that was a potential 2 lives that are now telling a story of a bad mason as opposed to a family telling the loss of their loved ones. This only happened relatively recently. This was not a gas alarm, it was a fire, but the building, it was an electric battery, unfortunately, and it wound up setting the building on fire. We call the FD. They respond, they find the building on fire. They didn't know there was a fire in that building until this unit went off, and we sent them. So here, unfortunately, 2 people died in this fire, but I will tell you, I'm pretty confident more would have if they were not, if they weren't there as quick as they were, potentially because we called them. So here's a quick graphic of a leak on our distribution system, cracked pipe, and we had 3 detectors in the surrounding area all go off, right? So once again, it's giving us, obviously it's measuring, it's giving us an emissions value, but there's a safety benefit, a cracked main on our distribution system, which is once again our use case. Our use case is something happens on our pipe. So Mark mentioned it a few times. He mentioned UL 1484, the governing standard for the device, NFPA 715, a new standard for installation. And I know people ask me, is your device installed in accordance with NFPA 715? And I say, absolutely not. Our use case is to protect our gas in the building and not provide protection for the entire structure from leaks. Like, if you look at this, I noted in the basement, we get a gas reading in the basement. Then, you have someone on the 3rd floor, hey, do I smell gas up here? It's just, it's an added benefit, but doesn't protect the entire structure. You could still have something happen on the upper floors. It will not detect it in the basement for obvious reasons. I should have put this slide actually first. So this is NFPA 715. This is a new standard. It was issued May of 2023. Con Ed and National Grid pushed for this standard, and we petitioned the AGA. The AGA submitted a petition to NFPA to create the standard, which was great. And now there is a governing standard for authorities having jurisdiction to adopt for requiring natural gas detectors by consumers, right? Not gas people. This standard does not, we don't comply with this standard. We don't install it in accordance with this standard. And our installation is not intended to meet this standard. But it was, the reason we pushed for it is because New York City had promulgated a law called Local Law 157 in December of 16. And that local law simply said the New York City Department of Buildings shall create or adopt installation and performance standards. And then once that's done, within a period of time, it'll be required in New York City. Well, it was funny, I told a colleague of mine, Ron works with Mark, Ron Lazarus, I said, I'm going to retire when 3 things happen. NFPA 7, UL is changed to 10%, NFPA 715 is issued, and New York City Local Law 157 has teeth through New York City Department of Buildings. Well, I'm happy to announce 2 days ago, on February 14th, the building code in New York City has been changed, and now every building in New York City, every apartment is required to have a natural gas detector. So that happened 2 days ago. So I'm officially announcing my retirement. No, I'm not. Maybe soon. All right, so that was a personal achievement. Rob showed a picture of the East Village, and you say, all right, you smell gas, supposed to react, and we, in the incident in East Harlem, people didn't react. In East Village, theft of service. But as we were in that East Village responding to that event, we found this sign in one building. We were checking for safety. And it really exemplifies how consumers treat natural gas many times, right? Plumbers were doing work, so there was gas smell, and the consumer said, hey, shut the door, I'm smelling gas. There was a leak in that room. It wasn't, the plumber wasn't even there, right? And this is what comes up, we have a Bronx explosion. Look, you just Google gas explosion, they're all gonna be around. Quick, Paul, you can't answer this.
I will not.
No, you will not. Okay, so the NTSB, right, it does major investigations of things, Department of Transportation related incidents. So there were 3 times they actually recommended natural gas detectors. 3 times. Anybody know any of those 3 times? The events that happened?
A Bronx home explosion?
No, but thank you. I appreciate that. That was too easy. Silver Springs, Maryland? The apartment complex explosion happened in 18. Okay, before the NTSB issued that report, I will tell you I was talking to that chief investigator for about a year and a half, telling her about natural gas detectors and what we were doing, how we were piloting, how we were testing. So I'm not surprised NTSB actually required natural gas to, be pushed in their report. But the first incident was April 22nd, 1974. It was a utility called Con Edison that had an explosion. And the NTSB, that's the first report, they actually recommended natural gas detectors be looked at. 1974. I knew you knew Silver Springs, Maryland. Do you know the middle one? There's many of them. It's hard to tell. Yeah, Allentown.
Oh, Allentown.
Allentown, PA, right. Allentown. All right, so thank you for the setup with this one. Bronx explosion. Maybe you've seen this video. That's a Ring camera across the street. All right? If there was a natural gas detector in that building, I'm pretty confident there wouldn't have been a person in that building when that building exploded, right? So, what happens, our GLA, gas leak alarm, our 9th GLA we received was in a building in New Rochelle, New York. We put a gas detector at Thomas Paine's cottage. Remember who Thomas Paine is? Any historians? Right, Thomas Paine, right, the author of Common Sense, right, why the United States should break away from Great Britain. And that's simply, and thank you, Mark, for saying that, and that's simply what I feel about natural gas detectors is their common sense. Questions?
So with the new requirement, like you said, that was passed in New York City, does the ones that you're installing, and they may be just down in the basement by the meter set, does that count for the residents?
No.
Or do they still have to add another one in the living space?
The residence has to add. Our commentary was that it doesn't count because the consumer is installing it by gas appliances, right?
Okay.
So it doesn't count.
And then if you are installing them and if the meter set's outside and your facilities are all outside, do you put some in those places? And
If
install
our
them
meter
in
is outdoors, we're putting it actually indoors. The unit that we're installing is not an outdoor detector, right? UL
Yeah.
1484 is not an outdoor standard.
So then you're installing it in the living space,
in
and
the
then
living
that meets the requirement for the homeowner?
Technically, it could if that room had a gas appliance.
Okay.
It could if the room had a gas appliance.
Are you seeing incidents of outdoor leaks where the plume's migrating through a basement wall?
Oh,
And
absolutely.
alarming? So they're not all inside leaks. There's
Yeah, no, absolutely. One of the slides of the 3400, 500 is outside gas coming in. Now, some of it might be through penetrations, meaning, a conduit, an electric conduit, right? Because the electric conduit comes to the basement. Others is through the foundation wall. Not that much, though, through the foundation wall, because that's a heck of a lot of gas.
right.
Right.
Maybe penetrations or
Most of it's-
cracks, maybe.
Yeah, definitely.
There's a lot of POEs that we have.
Point of entry. We call
A
them
lot of
POEs,
different
point of
ones.
entries, pipes coming through the wall.
Old stone foundations and old
I
buildings.
don't have a lot of those. There are some. I don't know how many are through, I call them rubble foundations. I don't know. Probably a couple of them.
Was it hard for them to set up some type of case to pay for them?
Well, you're Con Ed funding them?
Was it Con Ed or was it federal?
It's all right. So right, our installation is rate case funded.
Okay.
Right, so we get recovery. Our units, they go in as a capital asset, we get recovery of them. Right, that's how our units that go in.
Right.
The ones we gave away was simply O&M money that we hadn't expended on one case, and they said, okay, instead of refunding it to the customer, spend $2 million and give them away. And then the other one was a rate case order where they said, okay, here's $2 million, spend it and give them away. So two $2 million orders, which was settlement money.
And that was to satisfy all new buildings requiring a gas detector? Or
No, it satisfied, actually, the 61,000 had to be low income.
Okay.
So we had to give them to low income customers. And I will tell you, it took a long time to give those away for free. You have no idea what we went through to give those away. Double mailings, triple mailings. You know, here, put this postcard in the mail. We'll send you a detector. No response.
A couple questions. You mentioned a heartbeat. I presume that's your nomenclature for how you know the detectors in the field inoperable and all of that. What data do you get back at each of those instances? And if a detector stops reporting, what's your follow-on action for that?
A good question. So, we call it a heartbeat, and it just means that our AMI interface, records it. And of course, we have systems up to identify heartbeats that are not received over a period of time. And typically, sometimes it just loses connectivity to the network, and we just watch it for a day, and we see it reconnects to another meter. Doesn't happen that often. Sometimes it does disappear on us because it's in someone's house and they don't have a GPS on them, and I think people move them, so we've lost some. So we just go back out and reinstall them. So that it's not a perfect world with there. You put something in someone's house, you don't know what's going to happen.
The Rule 715, that's a New York City statute. Was there any thought of going through the rest of New York State from the legislature?
Okay, NFPA 715 is a standard that could be adopted, or could be adopted by any authority having jurisdiction. I actually had a proposal last year to the ICC International Residential Building Code. I put a proposal in to require natural gas detectors in all new buildings, and the proponents were outspoken by the opponents. And the board saw the value in it, but they thought it was premature to require it. And I will tell you, the opponents, National Society of Home Builders, opposed it. Home builders did not want it to put a gas detector in a house. There's someone else who opposed it, and I would not name them because you could ask me offline. I will tell you who else opposed it. You'd be very surprised. New York State was at this hearing. They supported it. But when it came down to it, the board decided it was too new, and they punted it. I will tell you, I have another proposal in to the ICC for the International Fire Code, and in April I'll defend that hearing. I'll defend that case at a hearing. So any authority having jurisdiction that utilize the International Fire Code, if it passes, will then get a requirement for a natural gas detector. So that would be, countrywide, whoever adopts it.
Just kind of to follow up what you just mentioned, what's the experience with a customer defeating or removing the device from their living space?
Well, we had the pot smokers, right?
Besides the pot smokers.
Yeah, that caused the redesign of the button. For the most part, we haven't really lost that many. We've lost some, and that was the heartbeat. The heartbeat disappeared on us, and we can't find it. We did find, one time, a heartbeat occurs, and someone's in the building, and they track ID numbers. But this was over there. How to get over here? So, sometimes it does happen. But if someone takes it and really plays with the button the right way, they're going to set it off no matter where it is. Well, actually, we had one case. I'm going to digress. So, for your question, we had one case where we had it in, I think it was Baruch, and the custodian smelled gas, and he took the unit and he brought it to where he smelled gas, and it went off, which was pretty cool.
Thank you, everyone.
All right.